In this video, we'll be learning how to write the equation of a line for a real-world problem. Throughout the next few slides, we're going to look at 4 different word problems, and in each of these word problems, we are going to encounter one of the following 2 situations. So every time we write the equation of a line, we'll be given one of these 2 situations. The first situation that we might see is we might be given 2 points. So we might be given 2 points that are on that line, and we'll have to write the equation using those 2 points. The other situation we might see is we might be given 1 point and the slope. So notice how in one situation we have 2 points, and in the other situation we have 1 point and the slope. And we'll be talking through how we write the equations for these different situations, as well as talking about how we are going to find those pieces of information within that word problem. Now here are 2 extra word problem hints before we begin. We'll have variables of x and y within these particular problems. 2 hints that I want you to be aware of and have written down in your notebook are that if time is in that problem, x will always, or typically always, be that time variable. So if you see time in the problem, that is going to associate with the variable x. If we have cost in the problem, that is going to associate with the variable y. So we will be asked in each problem, what does x represent and what does y represent? If time is in the problem, it will be associated with x, and if cost is in the problem, it will be associated with the variable y. So on the screen here, you'll see that we have a word problem, and typically, as we read through this word problem, I have students annotate or underline important information in the word problem itself. But what I'd like you to do, since you won't have this one in your notebook, is I would like for you to write down any key information that you see as we read through it together, or that you think might help us to find points and slopes. So this one says, your friend has recently released a new book that is on average selling 30 copies per day. By the 4th day of sales, 620 books have been sold. So when I read through this, the first thing that jumps out at me is this phrase that says 30 copies per day. So if I were you, I would have 30 copies per day written down in my notebook because that's something that is really important. It's a number and it's telling me that there are 30 copies of books being sold per day. The next piece of information that I find important is it says by the 4th day of sales, 620 books have been sold. So that's a piece of paired information. On day 4, 620 books have been sold in total. So now that I found my key information, I'm going to move on and answer parts A through D in the problems below. Part A says, what important pieces of information can we pull out of this problem? Do we have points, or do we have slope, or do we have, 2 points in there? So what I start looking for is the first thing I look for are points are represented by pairs of information. So if I see pieces of information that are paired, I know that that is representing a point. So that's what's happening right here when it says on day 4, 620 total books have been sold. So that is 1 point on my line. Now remember, I have to figure out which one goes in the x-coordinate and which one goes in the y-coordinate. Remember, x is typically represented by time, and in this case, days is our time. So here in our coordinate, we have 4 days, comma, 620 books. So that's a piece of paired information. That is my point. Then this other piece of information says 30 copies per day. So I don't see a pair of information, but what I see here is I see this word per. If you see per, that's a rate. I'm selling 30 copies of my book per 1 day. So this is a rate, and this word per tells me that I have my slope. So here, my slope, or my m value, is equal to 30, or you can write that as 30 over 1 if you would like. So here we have 1 point of 4, 620, and we have our slope. So that's the situation that we've been given. Now from here, my next step is to decide what x and y represent. Well, remember, I have a point up above here, and the first part of my coordinate is my x value, and the second part is my y value. So I can see here that x is equal to 4 days in my point, so x represents the number of days. And then here, y represents the number of books. So now my next step is I'm going to write an equation in slope-intercept form to represent this particular situation. So I'm going to take the information that I have. I have 1 point, which is 4,620, and I have my slope of 30. And what I'm going to do is I'm going to start in point slope form, just like I always have, and then I'm going to rewrite my equation into slope-intercept form. So if I go to point slope form, I know that in point slope form, it's y minus y1 is equal to my slope times x minus x1. Well, here I have x1 and y1, and I have my slope. So I substitute in my values, and I have y minus 620 is equal to my slope of 30 times x minus my x1, which is 4. So now I have this equation written in point slope form, and my goal is to rewrite this into slope-intercept form. So I need to rewrite this into y equals form. So I'm going to start by using keep, change. Then I know that I need to distribute here. So I have y plus negative 620 is equal to 30x plus 30 times negative 4 is negative 120. Then I add 620 to each side, so I end up with y is equal to 30x plus negative 120 plus 620 is 500. So this equation here represents my equation for how many books are being sold. So now this last part down here says use the equation that you found in part C to find how many books are sold on the 10th day. So we need to find how many books are sold on the 10th day. 10th day is the information that we are given. So we need to use this equation here, y equals 30x plus 500, to figure out how many books are sold by the 10th day. Well, what I'm seeing is I know 10th day, and if I look back up above, x represents my number of days. So what I can do is I can take x and I can set it equal to 10. So here I have y is equal to 30 times 10, then plus 500. So 30 times 10, that's 300. So what this problem tells me is that by the 10th day, I will sell 800 books. Okay, moving on to example 2. So again, we're going to record the important information here. So this one says, a maple tree grows at a steady rate. After being planted for 40 days, the maple tree is 92 centimeters tall. After being planted for 60 days, the maple tree is 132 centimeters tall. So what I'm seeing here is I am seeing two pairs of information. I'm seeing a pair of information at 40 days and a pair of information at 60 days. So I can make a point out of this, and remember the time, days, is going to go on my x-coordinate. So my first point here is 40 days, comma, 92 centimeters. And my second point is 60 days, comma, 132 centimeters. So anytime you see a pair of information, remember that is dictating that we have points. So here in this particular example, we have been given 2 points. Now, my next part of this problem says, what do x and y represent in words in this particular equation? So here what we have is we have x, y, x, y. And what I'm noticing is that x represents the number of days, and y represents the height in centimeters. So as we find our equation, x is going to represent the number of days, and y is going to represent the height in centimeters. So now we're going to write our equation ending in slope-intercept form. So we start off and we look at the information we've been given. We have 40, 92, and we have 60, 132. And so what I'm noticing here is I have 2 points, but I do not have my slope. So I'm going to need to calculate my slope value. So here we start and we take our 2 points and we label them as x1, y1, x2, y2, and we find our slope. So we have 132 minus 92 over 60 minus 40. 132 minus 92 is 40. 60 minus 40 is 20. So we see that our slope ends up being 2 over 1 or 2. So now that we have our points and we have a slope, we can write our equation into point-slope form to start, and then we will rewrite it into slope-intercept form. So remember, point-slope form is y minus our y1 value is equal to our slope times, in parentheses, x minus our x1 value. So we go back to our points and we have our point x1, y1, and we have our slope of 2. So we take y minus 92 is equal to our slope, which is 2, times x minus 40. Then from here, we're going to utilize keep, change, because that's going to make our lives a little easier. And then we will distribute. So we have y plus a negative 92 is equal to 2x plus a negative 80. Then from here, we want to get y alone so that it's in slope-intercept form. So we add 92 to each side. So our equation written in slope-intercept form is y equals 2x plus 12. So now from here we look at example D, and we're going to utilize our equation to make a prediction. So this says use the equation you found in part C to find how many days it will be when the tree will be 194 centimeters tall. So the first thing I'm noticing is that I'm given a height. My height is my y-coordinate. So what I'm being told here is that y is equal to 194, and my goal is to find x. So I'm going to take my y value here, and I'm going to substitute it into my equation. So I have 194 is equal to 2x plus 12. And now I need to rewrite this equation for x. So I'm going to start by subtracting 12 on each side. So 194 minus 12 is 182. That's equal to 2x, so we then divide by 2x, and we find that x is equal to 91 days. So this is telling us that at 91 days, our tree will be 194 centimeters tall. Okay, moving on to example 3. So this says James is ordering delivery pizza from Domino's. He knows that a medium pizza costs $5 per pizza. The last time he ordered pizzas, he ordered 10 pizzas for $59.50, which was the pizza plus the delivery fee. So we can see that we have 2 pieces of information here. The first one is a cost of $5 per pizza. This word per tells me that I have a slope. So my slope here is 5 or 5 over 1, because that word per tells me I have a rate, which is my slope. Then the second piece here, this 10 pizzas for $59.50, is a pair of information, so I have a point. Now I have to think through how my x and y are going to be organized here. Because $59.50 is a cost, that's going to be my y coordinate. So cost is always your y coordinate, so that's $59.50. So my x coordinates is 10 pizzas. So that's my pair of information. So here I'm given 1 point and I'm given the slope. So my next step is to determine what x and y are equal to. Here I can see that the x coordinate is the number of pizzas that I buy. I can then see that my y coordinate is my cost. So now from here I'm ready to write my equation. So I look at the information I have. I have a point of 10, 59, 50. And I have a slope of 5. And remember, I always start in point slope form, which is y minus y1 equals slope times x minus x1 in parentheses. So here I have my x1 coordinate, my y1 coordinate, and my slope. So I go ahead and substitute my values in. I have y minus my y value of 59, 50 is equal to my slope of 5 times x minus my x coordinate of 10. So now from here, I'm going to utilize keep, change, change. Then I'm going to rewrite it so y is alone. So I start by distributing. So I have y plus a negative 59, 50 is equal to 5x plus a negative 50. So I then add 59, 50 to each side, and I end up with y is equal to 5x plus 950. So here I have my equation that helps me to determine how many pizzas I can buy for a particular cost, or how much it will cost to buy a certain number of pizzas. So my last step here is I look down at part D, and it says use the equation you found in part C to find how much it would cost if he ordered 17 pizzas. So here I'm given a value, and I want to figure out the cost for 17 pizzas. Well, if I look back up above, x is my number of pizzas. So here I have x is equal to 17. So I'm going to substitute that into my equation. So I have y is equal to 5 times my x value, which is 17, plus 950. So if we take 5 times 17, that's going to be $85 plus 950, and that is going to equal a total cost of $94.50 if I want to buy 17 pizzas and have them delivered to me. And last word problem example here. So it says, Diana's making a long-distance phone call to her friend in Europe. On her last phone call, she talked for 16 minutes and it cost her $4.75. The time before that, she talked for 40 minutes and it cost her $10.75. So what I'm noticing here as I read is I have two pairs of information. I have a call for 16 minutes that was $4.75, and I have a call for 40 minutes that was $10.75. So because I have pairs of information, I know that I have 2 points here. And because I have time, the time or the minutes is going to go in my x-coordinate, and my cost is going to go in my y-coordinate. So as I make these points, the first point that I see is it was 16 minutes and it cost $4.75. And then my second call was 40 minutes and it cost $10.75. So those are my 2 points that I'm given in the context of this problem. Now my next question says, what do x and y represent in words in this equation? Well, here x, I can clearly see is my number of minutes because x represents 16 minutes and 40 minutes. Then y, I can see, is my cost in dollars. So I have what x and y represent in the context of the problem. Now my next step is to write an equation in slope-intercept form. And I know to get there I need to start with the information that I've been given. So here I have 2 points. I have 16, 475, and I have 40, comma 1075. So in order to write the equation of a line, I'm going to need my slope value. So because I only have 2 points here, I'm going to have to calculate my slope. So here I have x1, y1, x2, y2. And so I do y2 minus y1 over x2 minus x1. So 1075 minus 475 is 6. 40 minus 16 is 24. Now for this problem, having a slope that's a fraction can get a little nasty. So what we're going to do is we're going to take 6 and divide it by 24, and we're going to turn that into a decimal value. So this is 0.25. So here I now have a point that I can put into my equation, and I also have a slope of 0.25. So now I'm going to go back to writing my equation, and I know that I always start in point slope form. So I'm going to start by taking y minus y1 is equal to m times x minus x1 in parentheses. So now I'm going to substitute in my values. I take y minus 4.75 is equal to 0.25 times x minus 16. So then from here, I'm going to utilize keep change, and I distribute. So I have y plus negative 4.75 is equal to 0.25x, and then 0.25 times negative 16 is negative 4. So now I add 4.75 to each side, and I end up with y is equal to 0.25x plus 0.75. So here I have my equation that connects cost with number of minutes. So now I'm going to utilize this equation to make a prediction down below. So here if I read through, it says use the equation you found in part C to find how many minutes she talked on the phone if her call cost $9.25. When I look back up above, cost is y, so this is telling me y is equal to 9.25, and I need to find my x value, which is how many minutes I was on the phone. So from here, we take 9.25 and we substitute it into the equation. Now our goal here is to get x by itself, so we're going to start by subtracting 0.75 from each side. As a result of that, I get 850 is equal to 0.25x. Now to get x alone, I need to divide both sides by 0.25. If I do that, I end up with x is equal to 34 minutes.